Okay, time for some quick homework help with WebAssign for tonight. All right, let's take a look at this one. So we've got a boat moving through the water with two forces. You've got a forward push and a resistive push. So as you can well imagine, it would look rather like this. All right, you're told what the drag force is going to be, and here you've got your, a force being applied by the motor. Acceleration, well, that's just going to be bigger minus smaller right here. So hopefully that was straightforward. After that, after you've got your acceleration from using your net force equation, the main thing you want to do is to draw yourself a VT graph. You're starting from rest, it's getting faster, you're told your time final, and you're going to be looking for your velocity final. A reminder that your acceleration is the slope of that line. So you can very simply use the slope of the line to figure out your final velocity. All right, let's see if I can get this to switch. Maybe not. Got to go back to the computer. All right, let's turn the page. There we go. Last one for today. These are just to kind of keep you warmed up, everybody, so that you're ready to work with these, on a daily basis. All right. Oh, looks like we're levitating. I guess the smartboard's not calibrated, but that's okay. So this is at rest. You're given your angle of 30 degrees. This is totally not calibrated. Let's see if a different color does better. All right. Accelerates uniformly down the incline. All right. You're told the distance that it moves and the time that it takes to get there, right? So let's think about that. You're being told the distance it moves and the time that it takes to get there. You're being told TF, and you're being told the area under your curve, right? That's your delta X. So what you could do is you could certainly use your area and figure out your velocity, your final velocity, which quite frankly is D. I would do that one first. The acceleration of the black, well, probably the easiest thing would be to figure out your slope of the line right there. And that would give you your acceleration of the black. After that, you can start looking at it from a force perspective. All right, your free body diagram, mg, we've got friction because they're asking you to find it, so there must be some friction, right? Normal force. All right, so again, as we've done a few times now, mg sine theta is the force trying to go down the hill. Your mg cosine theta, that corresponds to your normal force, and your friction is trying to go up the hill. So when you're looking at the net force equation and you're thinking about bigger minus smaller, just remember this is trying to go down the hill, this is trying to go up the hill. My acceleration is down the hill, so my bigger one must be mg sine theta minus the force of friction. The force of friction, considering you know this, okay, really not calibrated. You can figure that one out. Then it's just algebra time, and you can figure out this one, right? When you go to do coefficient of friction, force of friction over normal force. And again, your mg cosine theta should match your friction. So make sure you're in degrees, not in radians, but that'll do it. That's it. Hopefully you didn't even need this help, right? But if you need me, you can find me at school.